Hello guys, today we're going to see 5 tools that Excel offer us for data analysis. First of all, we have a data set including age, work experience and salary of 10 workers. First of all, we have to regress age and salary to see whether they have some relationship. So we're going to go to data and then data analysis and click on the button that says regression and then OK. Our Y range is the salary, is the thing that we want to predict, and X is the age. So we want to see whether the age has an effect on the salary. We expect that as age increases, salary also increase. So the output range here is B15, so it's good. And we want the residuals also. And we click OK. Now we have some information that so what is Excel what Excel tells us is that when age increases by 1, when the person ages by 1 year, his or her salary will increase by 3,827 euros. And the intercept means that the salary of every person on average will start by 51,000 euros a year. Also, here we have the predicted Y, which is the predicted salary that our model has predicted, and the residuals is the difference between the actual salary and the predicted salary. So here the actual salary for worker 1 is 135,000, but our model has predicted 146,000. So our model has not done hasn't done a good job in predicting the salary, and that is expected because salary is not dependent only on the age of the person but also on other things as work experience, educational background, and others too. So this is the regression output. We will then move on to plot those two. So we choose age and also we choose salary. We go to insert, recommended charts, and then we select the scatter plot. Okay, let's move it here. Here we can see all the data points, the salaries of the people that work in this company and their age also. We want to see also a trend line. How can we do this? We click in one dot, we right click and go to add trend line. We are going to add a linear trend line, but also if we want to see the polynomial, for example, it is a more realistic way to see the pattern of the salaries, because linear, as you can see, is not that good in predicting. I mean, this point is indeed in the linear line, but other points are far away, so our model does not do a good job in predicting the salary, while a polynomial of second order, as you can see, it is more closer to the data points. Let us say that for us, age and salary have a linear relationship and not a polynomial for now. Also, we want to display the equation in the chart. Let's close that and let's see that. What is this relationship? If we zoom in a little bit, you can see that y is equal to 3,827 x, which is the coefficient that we found here, but also we add 51,000, which is the intercept. So it's the same result. That means that a person starts by 51,000 a year, and as age increases by one, he's getting paid more. How much more? $3,827 euros. I'm sorry. Then we're going to see the third, descriptive statistics. Here, what we want to see, for example, let's select salary and go to data and data analysis. We are going to go to descriptive statistics and press OK. Let's say that we want input of salary here, and the output we want to display it right here. Let's say we want to display it right here and press OK. Here we're going to see some numerical results like the count of the observations, the sum of the salaries, the maximum salary, 300,000, the minimum salary, the range, which is the maximum minus the minimum, and also the median or the mean salary. So that is a very helpful tool to see some statistic measures for your data. As we did for salary, we can do for age and work experience also. Fourth, the correlation matrix, which is very, very important. We go to data analysis and then correlation is very important. Let's say that we want to see whether the work experience variable and the salary are indeed linked together. They have a relationship. They move together or they move at opposite directions. So we choose the work experience and the salary, the data, and go to data analysis and correlation. We want the result, the output, to be right next to the descriptive statistics. Here we can see that indeed work experience and salary are moving together. They have a positive relationship. That means that when work experience increases, then salary on average increases too. So that is a good measure to see whether our data go together or they move to opposite directions. We expected that as work experience increases, salary will also increase. Last step is to do a regression, a multiple regression, including work experience also. So we want to go to data, data analysis again, regression, down here, press OK. Y range again for us is salary, and for X is age and work experience also. The output range, let's go here, right here, next to the correlation matrix, and press OK. Here we're going to see an identical table like the one before. The only difference is that we have a second variable also. So the X variable, as we said before, is the age, and the second variable now is the work experience. Now we're going to see some peculiar results, meaning that our intercept is negative. That means that on average, the starting salary is minus 7,700 euros. That does not make any sense. That means that we work and pay the employer to work for them. That is not realistic. I hope so. I hope so. So, yes, this is a problematic result, but it has a meaning and an explanation. As you can see here, we have not many data. We have 10 observations. So, for 10 observations, we have two variables. So, we are likely overfitting our results. We are not doing a great job because we have very few data. That's why we get these peculiar results. In order to get better data is to increase the data set and increase it.